Hello learners. So in today's lesson, want to consider motion under gravity. Motion under the influence of gravity. So considering vertical projection. So motion under gravity, vertical projection. And if an object is projected vertically upwards, the initial speed is ui, a is going to be minus g, right? An object is projected vertically upwards from the initial point O. So it is projected vertically upwards at an initial speed ui, at an initial vertical velocity ui. Acceleration is minus g because it is decelerating. So it reaches maximum height, h max. So at h max, the final vertical velocity will be 0 meters per second. The final vertical velocity will be 0 meters per second. The final vertical velocity will be 0 meters per second. So want to calculate we're going to calculate time to reach maximum height. So we're saying Vy is equals to ui minus gt. This is from V is equals to u plus at. So Vy is the final vertical velocity, ui is the initial vertical velocity, a is equals to minus g, right? So we're saying Vy is equals to ui minus gt. So at h max, Vy is equals to 0. So we'll have 0 is equals to ui minus gt max. So t max is going to be equal to ui over g. This is the time to reach maximum height. This is the time taken to reach maximum height, where ui is the initial vertical velocity, g is the acceleration of free fall, because we're neglecting air resistance. So we're going to calculate maximum height reached. Right? Calculation of h max, or maximum height reached. So our calculation will be based on this formula plus 2as. So this will be plus 2 minus gh, right? So because a is equal to minus g, so want to calculate the maximum height. So at h max, Vy is equals to 0. At h max, the final vertical velocity is 0 meters per second. So we'll have 0 squared is equals to minus 2 h max. So if we make h max the size of the formula, we have h max is equals to ui squared over 2g, right? So formula, so h so this is the maximum height reached relative to the point of projection. This is the maximum height reached relative to the point of projection. This is the initial vertical velocity, acceleration of free fall. So ui over g. So this is the time to reach maximum height. So we're going to move on to the calculation of time of flight. Calculation of time of flight. calculation of time of flight. Time of flight is defined as the time spent by the object. Time spent by the object in air, by the vertically projected object in air before it lands back. Time spent by the object projected vertically upward in air before landing back on Earth. Time spent by the object projected vertically upwards in air before landing. So I want to calculate the time of flight under three situations or under three cases. Right? Case 1, calculation of time of flight if the object lands back to the initial point of projection. Right? Suppose an object is projected vertically upwards. Suppose this is the initial point of projection. Suppose it is projected vertically upwards. So it will reach maximum height and land back, right, to the point of projection. So suppose this is the initial point of projection, so it becomes projected vertically upwards, then it lands back. So we've got this equation of total vertical displacement minus half gt squared. Remember, a is minus g. So y, total vertical displacement is 0. This object was projected from there, then it landed back. Total vertical displacement is 0. So our equation will be minus half gt squared. So we'll have half gt squared is equals to t. So this brings us to t is equals to 2 ui over g. So the time of flight will be 2 initial vertical velocity over g when the object lands back in the original point of projection. Right? So we say this is the lands back. Say y is equal to uit minus half gt squared. So y is equal to 0, total vertical displacement. So equal to 0 is equal to uit minus half gt squared. So half gt squared will be uit. This brings us to t is equal to 2i over g. So this is the formula for the time of flight if the object lands back to the original point of projection. Case 2. Second case number 2. Suppose the object lands at a point above the point of projection. Case 2. Object lands at a point plus h above the point of projection. very simple. So this is the initial point of projection. Then it gets intercepted there at the height of plus h, right? So y is equal to uik minus half gt squared. So the total vertical displacement is plus h. So we have an equation of plus h is equal to uik minus half gt squared. So the overall equation this will be the overall equation. From this equation, you must determine t, the time of flight. From this equation, you must determine t, the time of flight. So how do we determine t, the time of flight from this equation? It's very simple. So we're going to do it. So 0 is equals to half or level half gt squared minus uit plus h is equals to 0. So we're going to apply the quadratic formula. We can apply the quadratic formula. Then t is equal to minus p plus minus p squared minus 4 ac all over a. Right? P is the coefficient of t, which is minus ui plus or minus. P again is minus ui squared minus 4. A is half g times half g. C is plus h times plus h. This will be over 2. A is half g times half g. So here we're simply generalizing. So you simplify this, right? Becomes ui plus or minus, right? If you simplify it correctly, it becomes ui plus or minus ui squared minus 2gh all over g. If you simplify it correctly there, right? Then case number 3. Case number 3. Case number 3. Suppose the object lands at a point below the point of projection. Suppose the object lands at a point below the point of projection. Case 3. Object lands at a point below the point of projection. It's very simple. How do you go about it? So we simply say this is the point of projection. So it lands like this. This is the horizontal ground. Suppose the point of projection is this is h. So the total vertical displacement is minus h. So we use this equation minus half gt squared. So we have this equation uit minus half gt squared. So we have half gt squared minus uit minus h. From this equation, we should determine t for the time of flight. We should determine t, which is the time of flight. So how do we determine t? It's very simple. It's very simple as to how we determine t. It will be 0 is equal to half gt squared minus uit minus h. So ui is the initial vertical velocity, the acceleration of people. T is the time of flight. So we apply the equation, quadratic equation, which is p squared minus 4ac all over 3a. So this is going going to be basically minus plus or minus 4 half G minus H all over 2A all over 2A. So this simplifies to UI squared 2Z plus 2GH all over 2 times A half G. So 2 times half G to G all over G. So this is basically how it is done. So here you can substitute the actual values of U there, G, H, right? You can actually derive the formula to calculate the time of flight and come up with the answers and select the correct answers for the time of flight. So in our next video, I'm going to give you an exercise on vertical projection. Thank you.